So, let's go through some of the most interesting results of the paper. This graph essentially shows that hydrogenase 1 is oxygen tolerant. Now the enzyme is adsorbed onto the electrode and has electrons fired at it. Now because the atmosphere contains hydrogen, as the potential begins to increase, as does the enzyme's activity, which is measured in current. Now when oxygen is injected, you can see the enzyme activity plummets right down to near zero. However, it manages to recover and completely recycle back to 100%. When this is compared to the graph for hydrogenase 2, we can see that enzyme activity goes to a fairly similar level until it is hit with oxygen. Now, when this happens, the activity plummets down to zero and shows no sign of recovery. The reason hydrogenase 1 is oxygen tolerant is because when oxygen hits the active site, it binds with hydrogen and forms water. This essentially means the enzyme is working backwards. However, it gives it time to recover and allows it to again bind with hydrogen. In the case of hydrogenase 2, however, when oxygen hits the active site, it forms a complex with nickel, meaning the enzyme can no longer bind to hydrogen and rendering it useless. So, in summary, with oil levels sufficient to last us less than 100 years, it is imperative that we develop alternative sources of energy. The study of these two enzymes are at the forefront of research in the hope of making hydrogen fuel production more efficient. Now, the University of Dundee is one such institution attempting to do so, by offering PhD opportunities studying hydrogenase in relation to the production of biofuels. Everyone needs to realise the stark truth that our use of carbon fuels is not only finite, but is also destroying the planet. We will one day hopefully master the production of greener fuels and put an end to this planetary turmoil.